Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq bin Hashim, and I am the General Manager of this team. Today, I am going to talk about the application and examples of line integral assignment. Alright, our application of line integral is Ampere's law. So moving on, here we can see an example of line integral, which is Ampere's law. An interesting application of line integral is the mathematical formulation of Ampere's law, which relates electric currents to their magnetic effects. In appropriate physical units, Ampere's law states that integral C H ds equals to I, which is the current, and H is the magnetic field surrounding the wire. Together, they satisfy Ampere's law. H ds equals to I. Alright, so let's jump into our question 1. Let L be a very long wire, a planar section of which, with the plane perpendicular to the wire, is shown in the figure below. Suppose this plane is the xy plane. Experiments show that H is tangent to every circle in the xy plane, whose center is the axis of L, and that magnitude of H is constant on every such circle C. Thus, H equals to Ht, where T is the unit tangent vector to C and H is some scalar. Using this information, show that H equals to I over 2 pi r, where r is the radius of circle C and I is the current flowing in the wire. So I'm going to pass on to my fellow colleague Ammar Zafri to explain about the solution for this question.
Hi and Assalamualaikum. My name is Muhammad Ammar Zafri and I am the IT manager for this group. I am going to explain the solution for question 1. Okay, here we have circle C in the xy plane that has the radius of r centered at the origin, which is parameterized by ct equals to xt and yt, where xt equals to r cos t and yt equals to r sin t. And since we know that from the example, the figure shows us a circle, which tells us the limit for our line integral is from 0 to 2 pi. Moving on, here we have c prime t, which equals to x prime and y prime. Hence, we shall get negative r sine t and r cos t. After that, we shall calculate the magnitude of our vector, which we shall follow this particular equation, equation right here. So we input our x prime and y prime into this equation, and we'll do some simple calculation, and then we will get the output of r. Moving on, by Ampere's law, we know that I equals to h ds integrate to c. We need to show that from this equation right here, italic h equals to h ds over 2 pi r, we need to show that h ds equals to 2h pi r, where h is scalar such that h equals to italic h t, and the t is unit tangent vector to circle C. Therefore, t ct equals to lambda t times with c prime t. From here now, we shall we shall multiply c prime t to both sides shown right here. And then from here now, we shall do some simple calculation, and then we will get the output of the magnitude of the vector. Moving on. Lastly, we can put in the values of the limit and other values that I have explained earlier. So here we have bold hct times with c prime t dt, integrate from 0 to 2 pi. From here we know that h equals to h t which is shown right here, and ds change from ds to c prime t. And then from here, once again, do some simple calculation and integration, then we're gonna get the output of 2h pi r, and thus ultimately shows us that hds equals to 2h pi r. And thus, I have concluded the explanation for solution 1. I will pass um, this video on to my other colleague, which he will explain for question 2.
Hello, Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Hafiz bin Ahmadi and I am a secretary for this group. So, okay, the question 2 is consider the curve C parameterized by RT equal to T power of 2, T and ln T for range from 0 until 1. Evaluate the line integral with respect to arc length. The equation is integral C x square root of 4 exponent power of 4z plus y power of 2 plus 1 ds. From this, we substitute x into to t power of 2, y equal to t, z equal to ln t. ds dt for this formula, it is a square root of x prime power of 2 plus y prime power of 2 plus z prime power of 2. We substitute the t in this formula and we differentiate and get 2t power of 2 plus 1 power of 2 plus 1 over t power of 2. This we square root this formula and get the 1 over t square root for t power of 4 plus t power of 2 plus 1. And then the ds we get is 1 over t square root for t power of 4 plus t power of 2 plus 1 dt. Okay, so I pass to my friends who will continue my solution for question number 2.
Okay, thank you to Mama Hafiz. Okay, my name is Khairul Aiman. I'm an engineer for this group. I will continue the solution from question 2. Okay, as we see here, integration 0 to 1 t square root 4 t power of 4 plus t square plus 1 multiplied by the ds 1 over t square root 4 t power of 4 plus t square plus 1 dt. So we make a basic calculation here and we get the answer from this question is 17 over 12. So that's all from our group. Assalamualaikum and thank you.